Let's now do our first t-test. You'll find that most of this is exactly the same as for a large sample test. The only thing is that we now have to worry about degrees of freedom, find an appropriate t value in the table, and use tcalc instead of zcalc. Here's the problem. A large financial institution buys an econometric service for about $10,000 per year. The first part is not important. After a few years of using this service, questions are raised about its accuracy and cost effectiveness. It is found that of 20 financial data numbers forecast by the service, the average percentage error was 12.4%. The standard deviation of the percentage forecast error was 23.7%. Is the average percentage forecast error significantly greater than 5%? And use an alpha of 1%. Okay, let's write down all our sample data. Okay, so sample n is equal to 20, sample average of 12.4%, and sample standard deviation of 23.7%. And the question is the average percentage forecast error significantly greater than 5%, but remember the word significantly will be considered a weak word in statistics, so is the average percent error greater than 5%. So this is again a one-tailed test. And so we have to figure out which tail. Remember, we want the sample value, the x bar, on the same side of the distribution as the critical limit. So we go through the routine. X bar is 12.4%, and we compare it to the fixed given value. 12.4 is clearly greater than 5%, so it'll be in the upper tail. So we do an upper tail test. And the alternate now has the greater than sign in it. So instead of x bar being greater than 5%, we do the population equivalent, mu being greater than 5%. Now we can write down both our hypotheses, both the null and the alternate. Alright, so the null, we'll leave for a second, the alternate, mu greater than 5, and the null, everything else, mu less or equal to 5. If the average forecast error, average percent forecast error is greater than 5%, then the, if you like, the error is too high, too large, and so for the null, the error is not too large. Right, at this point, with any averages problem from here on out, we check the degrees of freedom. Degrees of freedom is n minus 1, and in this case the n is 20, minus 1 is 19, which is less than 30, so we'll use the t with 19 and do the small sample test. so let's now draw a diagram. So this will be the T with 19 degrees of freedom. Upper tail test with an alpha of 1%. Okay, so we're going to the tables, look for T with 1%, 0.01 in the tail. Okay, so 19 degrees of freedom and 1%, so 19 and 1%, it's 2.539. This is an upper tail test, so the critical value that we're going to use is a positive 2.539. And from here we can make our decision rule. If we get a calculated t-value less than 2.539, it's possible the error is not too large. If we get a calculated t-value greater than 2.539, it is likely the error is too large. Alright, so let's write down our decision rule. So if tcalc is less than or equal to 2.539, null is possible, do not reject the null. It's possible the error is too large, is not too large. In other words, it's possible the average percent forecast error is less than 5%. Alternatively, if tcalc is greater than 2.539, we can reject the null. Sample value is sufficiently large enough, and therefore we will accept the alternate. It is likely the error is too large, or we can say it is likely the average percent forecast error is greater than 5%. Now we do our calculations. We start with standard deviation, S of x bar, S divided by the square root of n. S for this example was 23.7 divided by the square root of the sample size of 20. Let's go to Excel to do that calculation. This is equal to 23.7 divided by the square root of sample size of 20, and that's 5.299. Now we can do our tcalc. Remember, tcalc is just like the zcalc. X bar minus mu divided by S of x bar tells us how many standard deviations there are from between the hypothesized average and the sample average. So x bar, the sample average was 12.4, minus mu, value in the null hypothesis, the 5%, and the standard deviation, which we've just calculated, 5.299, and the value for that is, going back to Excel, 12.4 minus 5 divided by the standard deviation, and that's 1.396. And now finally we're ready to make our decision. 1.396 is in the acceptance region, and so we will go with part 1 of the decision rule, not to reject the null. Decision, since tcalc is equal to 1.396, which is less than the critical value of 2.539, do not reject the null. In other words, the sample value is close to the hypothesized value, even though it may not look like in this case. And we can say, as above, it is possible the error is not too large. Alternatively, we could say it is possible the average forecast error is not greater than 5%. Or using the word significantly, we could say the average percent error is not significantly greater than 5%. Okay, and that's this test.